beautiful people, and welcome. In this video, we are talking about geometric series, specifically infinite series. Now, in a different video, we are going to be talking about geometric finite series, but that is going to be in a different video. As always, disclaimer time, if I make a mistake, I am human. Just let me know where the mistake occurs, so that way I may learn from it, and then you may learn from my own mistakes. All right, let's jump in. Geometric series, specifically infinite series. Here is your formula. S sub n is equal to S sub 1 over 1 minus r. Now, here is the big thing about infinite series. This only works if the series converges. Now, what does that mean? It means that an infinite series, let's say we have a series of a sub 1, a sub 2, so we have a number in the first position, we have a number in the second position. When we add all of them together, each partial sum goes to a particular number. The more numbers we have, the closer we get to a specific number. So an example of this would look like this. So let's say we're graphing for an example. And let's say we have a vertical asymptote. And our sequence looks something like this, a series. So the more we have, the larger numbers or the more terms we have, the closer we get, for an example, to this number, whatever this number is. Let's say this is, I don't know, let's call this number A. Probably not that number. Let's call this B. So if we have more terms, if we have 30 terms, we get closer to B. If we have 50 terms, we get even closer to whatever number this is. If we have 1,000 terms, we get even more closer to this B. The sum converges. Now, the opposite is kind of also true. If it does not converge, this is called divergence. If we do not get exponentially close to one specific value, that means we do not have a sum. So how do we know if a geometric series will converge or diverge? This is where we do the R test. Remember, R is our common ratio. So if we take the absolute value of our common ratio and that absolute value is less than 1, then we can assume that yes, it will have a sum. However, if the absolute value of your common ratio is greater than or equal to 1, the series does not have a sum, therefore diverges. So how do you answer something if it's asking you to find the sum of a geometric series, but it is a diverging series? All you have to do is just say does not have a sum, diverges. That's all you have to do. All right, let's go ahead and do an example. So notice, because this is infinite, I don't know if I said finite earlier. These are infinite series. So because we're doing infinite series, the upper limit does not exist. We're going all the way up to infinity and beyond. So it's in your sequences, it's like your dot, dot, dot. It will continue. As long as the pattern goes, it will go. You can always add more. You can always multiply by more. These are geometric, so you will always multiply by more for these. Notice that your index, right, your lower limit is not 1 on this one, so be careful. Okay, be extremely, extremely careful on this. Alrighty, let's go ahead and jump into an example. Sorry about the little wait here, little pause. I have so many papers that I just want to push aside, so that way I may focus on this. All right, let's go ahead and get started. So our formula, see, and I already moved my formula. How silly is it? There it is. Okay, our formula is S of n, or in this case, S of infinity, because we don't have an upper limit, is equal to a sub 1 over 1 minus r. Now, before you jump into solving anything, be extremely careful about your steps. These are your 2 steps, technically 1, technically 2. The only step that you need to worry about is to determine if a series converges or diverges. If it converges, then your absolute value of your common ratio is less than 1. Then you use the formula. If it diverges, your common ratio is greater than 1 or equal to, and the sum does not exist. Therefore, it diverges. Or it diverges, meaning the sum does not exist. So how do we figure this out? This is where you need your cheat sheet for your formulas. You're looking at your formula here. This is your formula. Now, this formula is a geometric sequence formula. So if you're looking at your equations, or the equations from the previous video for the geometric sequences, you're trying to see which one it matches to. Now, you're gonna always have explicit rules for your formula. So I'm looking at the formula here. Which one does it have? So look at my n. My n does not have a -1. So for my explicit rule, this is the one I have. So that means whatever is in front of my r to the n power is my initial term, or n of 0, or a sub 0, a sub 1. So a sub 0, excuse me, I think I said a sub 1 there subconsciously. So this a sub 1 here is your first term. It's not a sub 1 as in like the term in the first position. It's whatever the first term is. In this case, our first term is in the 0th position. Now, what is the first term in the 0th position? Well, look at the number in front. My formula says I have a sub 0 times r to the n power. And you guys, I did it subconsciously, but I don't think I mentioned it. The reason I can proceed is because in my head, I did my check. The absolute value of r needs to be less than 1. So my r, right here, my formula, my r is 0.8. 0.8 is in fact